Okay, so I'll do two quick things. So these are some things that were giving me headaches a while ago. So we're trying to address these headaches. So in Glamorous Toolkit, this is the loading dependencies. So it's quite a mess. Not a mess, but we are loading from 82 repositories, 124 baselines, and 489 packages. So managing dependencies here, can be a bit more intense. So for that, we're building some tools in order to just help us manage this and make it a bit easier. So if I inspect a baseline, I'm looking in Coder at a baseline, in this case, baseline of block. Now we have here a small tool called dependency analysis. And what this does is it goes through every package in the baseline. It gets the dependencies of that package in the code, and then it also gets all the dependencies specified within the baseline for that package. So then it can often be, like even for this project, for this package, that we are having, so in the code, we are having more dependencies than we are declaring in the baseline. So like this package depends, for example, on block and block text, and we declare these dependencies in the baseline. But then it seems it also depends on these packages with red, which we do not declare in the baseline. So maybe somebody was editing this and slipped some dependencies that were not declared in the baseline. And then we also have dependencies to standard Pharo classes that we have the notion of preloaded dependencies, or preloading baselines within the image. So these tools kind of help us to see in the baselines what are the dependencies that we have, and then what are the dependencies that we declare, and bring the two in sync. And this also works when we are inspecting other things. So here I'm looking at the same package. So now I'm in the package coder, I'm looking at the package, and I have the same tool. So when I look at the package, we know from which baseline that package is coming. So what is the baseline loading the package? So then we can compute again the same dependencies. So whenever I look at the package, I can see, is this package loading has more dependencies than declared in the baseline that uses the package. So this kind of helps us, and then we're trying now to also run this automatically on the CI so that it will fail and that we will detect these dependencies as they happen, or this breaking of dependencies. And what we started to add, we have dependencies, but I add a new dependency. Should I add it? Shouldn't I add it? So we extended the manifest of packages with something that we called allowed dependencies. So we can go to a package and say, this package is only allowed to have these dependencies. And any new dependency will break the build. It takes some manual work to add this to all those hundreds of packages, but in the end, if you have new dependencies, you have to think a bit. Do I want this, or I should remove that? So this was about dependencies. And then another thing that was a problem, and it was wasting lots of time, was loading GT. So we're using Metacello. So if we can load GT with the first script here, and that takes, right now in Pharo 10, around 40 minutes. So we build another, okay, so Metacello is not really GitHub aware, so it's like meant to work with everything. So then we made another loader, so it's a project loader, and to this one can load GT in around 8 minutes. So it actually makes it possible for us to start the day by loading GT fresh from sources every time. So it makes that a possibility. Before it really wasn't. So before it was quite impossible to do that. And just to give you a very quick insight into what this does, so it builds more or less, it tries to get those dependencies and build really a loading map beforehand, and then only load things once, and only analyze the baseline once. A big slowness in Metacello comes because it tends to analyze things multiple times and clone multiple times, so in the end, it wastes lots of time. So for example, we have this workflow, and then we get exactly the list of actions that's going to be executed in order to load the project. And this is like, it clones a project only once, it loads a package only once, so it really does what it should do. And then the fun part is that when we create releases of GT, so we also want to be able to build this map without having to clone. Because if we want to build this dependency map and we need to clone 82 repositories, it takes time. So what we are doing, and I'll just show you not everything, but a quick thing. In GT, every time we have a release, we also publish all the metadata about dependencies within a JSON. So we're not necessarily in the baseline, also in a JSON next to it. So what this means is that we can just parse that JSON and get back dependencies, and then do that recursively and build this whole dependency map just by request to GitHub without having to clone 82 repositories and wait And that kind of simplifies our life and makes these dependencies and loading a bit more manageable. Yeah, not perfect, but still enough to be able to work with it. That's all. That was all. Thank you.